Hi, everyone, and welcome back to my channel. If you're here, chances are you are getting ready for a big math standardized test. Whether it's the Praxis, T's, GED, CT, or ACT, let's be real, the math section can be a major hurdle for most people. But what if I told you that despite the names on these tests, they all have some similarities, okay? They often test the same exact core math skills. That's right. There's a common thread. And once you identify it, you can laser focus in to have a successful score. Now, in today's video, I am cutting through the noise to reveal the top 10 essential math skills that you more than likely will be guaranteed to show up on your exam. Well, I'm not going to just be listing them, but I created a formula sheet that will go through these top essential skills. There's two of them that we're not going to touch as much because it just depends on what they decide to give you. But we're going to go through the essential skills on the formula sheet. And I am going to do one skill for each. Okay, one or more skills for each of the essential skills. So I'm going to break it down. I'm going to tell you how people think through. I'm going to tell you what people misconceptions are and things like that. Okay, so grab your notebook, grab a pencil, which is preferable. But if you have a pen, okay. If you have a pen, okay. But let's dive into mastering these crucial math skills to boost your test score. And I got something to tell you. I threw in a bonus. So the sheet that I'm about to share to go through and do all the work, I made it available for you. So below, you can click on the link to comment on it as I go through it. So you can type in notes or you can download it as a PDF and use it, to follow along with me. Okay, so I will advise you to do that first. Click on it so you can have it up and you can comment or print it out so you can fill in the notes as we go through. And of course, this is a video, so if you're not able to do it right away, you can always go back to it and do it. All right, so let's get started. Let me go ahead and share the material so that we can get started. All righty, here we go. Are you ready? Are you ready? I'm going to share with you my formula sheet, and I'm going to go through and do these problems, talk it through, and let's see. Okay, so let's get started. So, alrighty, so we have the name of the sheet is the Math Skill Formula Sheet, okay, by me, Adrian Cox-Settles, who is the founder and owner of Diverse Interactive Learning Tutoring Center. Again, my name is Adrian Cox-Settles. I'm the founder and owner of Diverse Interactive Learning Tutoring Center, okay? So the sheet provides common formulas you might encounter across various standardized tests, like we talked before, the Praxis, the T's, the GED, SAT, and ACT, and others, of course. So it's crucial to understand when and how to apply these rather than just memorizing these. Okay, so in my years of tutoring and teaching, I have noticed a lot of my students might have said, or clients might have said, I don't know when to use this formula. I don't know what formula to use. So it's always a lot of confusion. So what I'm going to do is go through and break it down and so you can kind of see when to use it, when not to use it. And I know a lot of times there's letters which are variables on the formula sheet and you're trying to figure out what does that mean. So I'm going to break it down right now. So okay, let's go in, lock in. Okay, so the first section that we're going to go over is number sense and operations. Okay, so number sense and operations pretty much is the building blocks, needed for all the math to come afterwards. It's like the foundational skills, okay? And so the one that I'm starting with first, okay, let me go through and do this so I can annotate really quick. Okay, so what I want to start off first, I want to start with fractions, okay? Now, all the tests that I spoke about before all contain fractions, okay? Fractions are your friends, okay? It's a relationship between a part and a whole, the fractions. All right, so let's look at the examples that I put here. We're going to be adding and subtracting. Find the common denominator. You know, the denominator is the number on the bottom. So I'm going to rewrite this for A. So we have 3/7 plus 1/7. Okay. So 3/7 plus 1/7. Okay. So the top number is called the numerator and the bottom number is called the denominator. Think about the denominator as being down. It's the one that's down. Okay. So the numerator and the denominator. So the denominator is pretty much the total amount of pieces that you have. And the numerator are the specific pieces that you're discussing, okay? So it was the part on the top, and then the whole thing is on the bottom. So if you have 3/7 plus 1/7, when you do this, since we're talking about the total amount on the bottom, it's going to stay the same. Okay, the total amount of pieces is still 7 pieces, but we just add in 3 part of the pieces with 1 part of the piece, which is going to give us 4/7. Okay, so 3/7 plus 1/7 is equal to 4/7. Okay, like 1 apple plus 2 apple is equal to 3 apples. Okay, the apple stays the same, so the 7 stays the same. You just add the numerator. Okay, then when we go to the next one, we have 3/7 minus 1/7. Okay, and addition or subtraction, the denominator still stays the same when there are like denominators, okay? So the 7 stays the same, and we just go ahead and subtract the numerator. So 3 minus 1, which is 2, okay? So this is how you add and subtract common denominators. That means denominators that are the same, okay? So let's move on. Okay, let me go ahead and do this. Let's move down and let me erase this part really quick, quick. Okay. So let's move down to the next part. Now for the next part, we're doing multiplication fractions. And then a lot of times when people look at the formula sheet, they see all these A's and B's and C's. So in algebra, they're called variables, okay? But when you're just doing basic math, sometimes you're saying A's and B's. I don't even know. I haven't gotten to algebra yet. So let me explain it. A is representing one particular number, B is representing a different number, okay? So you know the numbers are different when the letters are different. So let's go through and tackle this. So the fractions I decided to do, let me see, where is it? I decided to do 3/4 times 1/4. Okay. 3/4 times 1/4. Now, when you have multiplication of fractions, okay, you multiply the denominator. Okay, you multiply straight across. Okay, you multiply straight across. Sometimes you can cross cancel out when they have common factors or in common, but for this right now, we're just gonna go straight across. So 3 times 1 is 3, and 4 times 4 is 16. So 3/4 times 1/4 is 3/16. Okay, it's 3/16. And so that's all you do. So basically, right here, it's just telling you A over B, which is 3/4, times C over D, which is okay. So let's say this is C over B. Okay, C over B, because the B's have to be the same because I have 2 4s. C over B, which is 1/4, equals 3/16. Okay, sometimes you can simplify it when there's a number that could divide into both, and that's called the greatest common factor. But right here, 3 and 16 don't have any numbers in common except for 1. And so you don't simplify it when you just have 1 because it's going to give you 3/16 again. So this is simplified. Okay, and they consider this to be prime. Sometimes they say the prime number or the prime fraction. For this is called a prime fraction because you can't break it down any further. Okay, so this is how you do the multiplication of fractions. And like I said before, sometimes you have to go through and simplify it, reduce it. You take a common number and you break it down. So let me just give you an example because people tend to have problems with this. Let's say you have 3 over 12. Okay, 3 over 12. And you say, wow, is this simplified? Can I reduce this? Now, the way you think of it, you say, okay, you're looking for the greatest common factor. Okay. GCF. Now, factors are numbers that break down into the number. Like, for instance, 10. 1 can go on the 10, 2 can go on the 10, 5 can go on the 10, and 10 can go on the 10. So those are the factors of 10. Okay, those are the numbers that can divide into it. 10 is divisible by 1, 2, 5, and 10. Okay, so when you're trying to break down a fraction, you look at the number and you say, is there one number that can divide into 3 and 12 evenly? That's not 1. Because if you divide 1 into a number, you get the number back. Is there a number that can go into 3 and 12 evenly? You think about it. Wow, 3 can go into 12 and 3 can go into itself. So let me divide it by 3. So you divide the numerator and the denominator by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So the simplified version of this answer will be 1/4. Okay. Now you can't break down 1/4 any further. So this is considered to be a prime fraction. Okay, a prime fraction. And so that's how you break it down. You look for the greatest common factor, a number that they have in common, and that's how you break it down. Okay. Now, let me go to division. Okay, let's look at the division of the fractions. Now, again, let me change this to a B since I have 4 both times. Okay. The same letter means the same number. Okay. So I have 3/4 divided by 1/4. Okay. So when you're dividing fractions, it's different than multiplying. Multiplying, you can go straight across. Now, for division to occur, you have to change it to multiplication. Okay. And sometimes people say you keep, you switch, and then you flip, or you keep, you change, and you flip. They say those different things. So you always keep the first fraction. So we keep 3/4. The sign, which is division, we change it to multiplication. Like I said, you keep, change, flip. Change mean you change the division to multiplication. Okay, so you change the division to multiplication, and when you flip it, you put 4/1. Okay, you invert it, or in math we say you do the reciprocal. Okay, so you keep the first fraction, you change the division sign to multiplication, and then you flip the second fraction, which is you invert it, or you do the reciprocal. Okay, and then once it's in multiplication form, what do? You can multiply straight across, and sometimes you can cross cancel out. I'm gonna do it both ways really quick. Okay, so 3 times 4, which is 12, and 1 times 4, which is 4. Okay, and when you do that, you get 12 divided by 4, which is 3. Okay, or some people might have done this: 3/4 times 4/1, and diagonally they see that these numbers are the same. See that? And so you can say 4 goes in the south 1 time, you can divide it out. That's 1. 4 goes in the south 1 time, that's 1. And then you can go through and say 3 times 1, which is 3, and it'll be over 1, which is equal to 3. Okay, so that's like cross cancellation. A lot of times you might have these really big numbers and you don't want to multiply through, and you see like a common factor, so you might just go ahead and cross cancel out. That'll help simplify the fraction really quick, so you don't have to multiply big numbers. So it was up to you. You can multiply big numbers, and then you can just keep simplifying, keep simplifying, keep simplifying, or you can cross cancel out with the biggest, greatest factor to help simplify it for you really quick. So it's all up to you. There's so many different ways to do math. Okay. All right. So let me see. Sometimes I can't even see this. All right. Okay, can I just go ahead? Let me just go ahead and clear it. Okay. Now, let me go to the next one. Now, the next thing we want to do is our percentages. Okay. Percentages, percentages, percentages. Yeah, sometimes people struggle with percentages, but it says percent means per 100. Okay, percent means per 100. Let me see. Can I do this right here so you can see? Okay, let me just do this. Percent means per 100. Okay, per 100. Okay, so per a lot of times means, division. Okay, so for instance, if you're trying to do something, it says, for my example, it says change 2% change 2% to a percent. Well, it's supposed to be changed. Yeah, change 2% to a percent. All right. We want to do this. We want to change it to a fraction. So let me just say change it to a fraction instead of a percent. Okay, let's do that. Sometimes we change fractions to percent, but in this case, we're going to change 2% to a fraction. And remember, I said that percent is per 100. It always have to do with 100. So 2% will be 2 out of 100 or 2 out of 100. You can write it as a slash if you want to, or on top, 2 out of 100. Okay. So if someone says, what's 2%? It means you got 2 correct out of 100 problems. That's 2%. Now, if you want to simplify this, you can, but this will be good in a lot of cases. They want you to write 2 as a percent. It'll be 2 out of percent. But if you really wanted to simplify it, you can say, oh, okay, 2 can go into both of this. Both of these. So 2 going to 2 one time, and 100 divided by 2 is 50. Okay. So 2% as a fraction will either be 2 over 100, but simplified would be 1 over 50. Okay. It's the same, but it's just in a different form. All right. Now, let me finish this. Go to the next one really quick. Now we want to look at part to whole relationship. Okay. Part to whole relationship. Now, you might have a percentage problem that might say, what is 2% of 100? Or what is 50% of 20? Or what is 30% of 50? Sometimes you really have to go through and work it out, whether you're getting clothes discounted or trying to get a tip or trying to figure out a tip and things like that. Okay, so I'm going to do this really quick. It says, what is 2% of 100? So this of right here means times. Okay, it means times. In math, you can have the x for times, but when you get to algebra, you want to have the ray dot because we can no longer use x for times because we use x for numbers. All right, so we're gonna use the x right now since we're doing foundational math. So 2%. So I'm gonna write here 2% of 100. Now, there's several different ways to do this, several different ways. So in math, they always tell you, you change the percent to a decimal. Okay, how do you do that? You change 2% to a decimal. So you got 2%. Under the percent sign or behind the 2, there's an imaginary decimal point. Okay, and you have to move it 2 places over to the left. 1, 2. Okay, you move it to the left, and when you do that, the percent sign drops. So 2% is really 0.02. Okay, so now you have 0.02, and you're going to multiply it by 100. Okay, you're going to multiply 0.02 by 100. There's different ways to do this. Now, one particular way you can do this is to move the decimal place over 2 because you have 2 zeros. Or we can just do it the old-fashioned way and just multiply this by 0.02. Let me just do this so you can just see it like this. Okay, so that's 0, that's 0, that's 2. And then the next 0 you don't have to do, but I'll go ahead and do it. Put down the 0 as a placeholder. 0, 0, 0. Okay, I did extra, but you don't have to. Okay, so this is going to be 0, 0, 2, 0. And then there's 2 decimal places. So you want to move it 2 decimal places to the right. 1, 2. And so the answer is 2. Okay, so if you got 2 problems right out of 100 problems, then you got a 2%. Okay, but we're trying to figure out what number do you get when you do 2% of 100, you get the number 2. 2 is 2% of 100. Okay, there's several different ways of doing this problem. This is the first way that came to my mind, so this is the way I did it first. But there's so many different ways, so many easier ways to do it also. Okay, so let me clear it out and let's move on. All right, let's go down further. Now, when you talk about percent, also you talk about something called percent change. You might have a percent increase, you might have a percent decrease, but they call it percent change, okay? Now, the formula for the percent change, as you see, it says the new value minus the original value, all divided by the original value times 100. Okay, so let's see this in a real example that I created for you. Okay, so my example. On Monday, Amy fundraised $50. On Wednesday, Amy fundraised $100. Find the percent of change. Okay, so first of all, you look at this and you say, is this a percent decrease or is this a percent increase? Which one? So you think about it. Did it go up or did it go down? Now, from 50 to 100, this is saying that it went up. So this is called a percent of increase problem, but you can use the same formula for increase or decrease. You can use the same exact formula. It's just one might be negative, but you have to take the absolute value of it. Okay, so let's do this one. So it says use the new value. I'm following this. So the new value, she went from 50 to 100. So the new value is 100 minus the original value was 50. What did she start with? All over. What was the original value again? It was 50. Okay, so we set it up like this, and then we multiply it times 100%. Okay, so let me move it over here. So 100 minus 50 is 50, and you bring over the 50, okay, times 100%. Okay. Now, you know, 50 over 50 is equal to 1. Okay. Any number over itself is equal to 1. So 1 times 100% equals what? 100%. So the percent of change was 100%. It increased the 100%. It increased the whole amount. Okay. So it started at 50 and it went up 50 more. It increased the whole amount. Okay. 100% mean you're taking a whole thing. It's a total increase. Okay. The whole exact value. So this went up 100%. Okay. So this is the percent of increase, which was 100% from $50 to $100. It doubled. So it went up to 100% increase. Okay. Now, all right. So let me erase that. All right. Let's go to the next one really quick. It's a lot of problems. So I'm going to move through. It's a lot of problems. I decided to go through it all. So this is what I'm doing. All right. Now, algebra, my favorite topic. Okay, algebraic concepts. All right, linear equations. Okay, linear equations, the equations that make a straight line. The equations that make a straight line are called linear equations. Linear stand for line. Okay, now we're talking about the slope-intercept form, and I know you heard this in school so many times. Y equals mx plus b. Y equals mx plus b. Yes, that formula is stuck in a lot of people's heads, but a lot of times people get confused. What does that mean? Why is it a y? Why is it m? Why is it x? Why is it a b? Okay, so let me break it down for you really quick. Okay, y equals mx plus b. All right, so M, they said, is the slope. Now, the slope determines the steepness of something, how it's slanted, how steep something is. That's the slope of the line, okay? And then the y-intercept talks about how that particular line intercept the y-axis on the graph. You have a y-axis and you have an x-axis. So how the line crosses the y-axis, that's the y-intercept. All right, but right here, only thing we're doing is picking out what number is the slope and what number is the y-intercept. Okay, so if the formula is y equals mx plus b, and you get a form something like y equals 3x plus b, 3x plus 6, then you look at it. If everything is lined up correctly, the y is, the y is over top of the y. You have the variable x over top of the variable x, and then you have the constant. That's just a little number hanging out. If everything is lined up correctly, remember the slope is the m, so the slope is 3. Okay, the slope is the number in front of the x when y is isolated. Okay, and then the number that's left dangling on the side is 6, positive 6. Okay, so the y-intercept is positive 6. Now, if it was 3x, if it was y equals 3x minus 4, then the y-intercept will be negative 4. Okay, so the b will be equal to negative 4. A subtract 4 makes it a negative 4, but a plus 6 makes it a positive 6. And then let's say you just had y equals 3x. And you say, what's the y-intercept? Since you don't have a number for the y-intercept is equal to 0, so you can put plus 0 here. And so the b will be equal to 0. That's the y-intercept. Okay, so those are little examples for you when it comes to that. All right. So what I'm going to do is erase that, and we're going to move down to the next part. All right, now you have something called the slope formula. The slope formula, I know you heard of this, because students, when you say what is the y-intercept, sometimes they say the y-intercept is y2 minus y1 over x2 minus x1. They get them all mixed up. They mix up the formula. Now you use the slope formula, you have 4 coordinates. Okay, that means you need 2 points. Okay, so we're gonna go through this. I'm gonna break it down. So many people get so confused. Okay, I'm gonna write it this way. M equals y2 minus y1, y sub 2 minus y sub 1 over sub 2 minus x sub 1. Okay, so this is one formula you can use, or you can use this one. M equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Okay, it doesn't matter which one you use as long as the 2's are over each other and then the 1's are over each other. And of course, you have to put the y's on top because in the formula it's called the rise, which is the y-axis, the rise over the run. You know, you run left and right. Okay, it's called the rise over the run. So sometimes you see it also like this too. I'll do this real quick. M equals, you see delta y over delta x. Okay, sometimes you see that. Delta means the change. The change means the difference. The difference means subtraction. So sometimes you might see it like that. There's so many different ways to see it, but these are the 3 main ways you will see the slope formula. Okay, now what does all this X and Y mean? What's this all that stuff? Okay, that's what people always ask. What's all this X and Y? So let's go through and label the points. Like I tell my students, the first thing you need to do is to label the points. Okay, so you have your first point, you have X1 and Y1. Okay, you have your second point, you have X2 and Y2. Okay, so in each point you have a X and a Y, just like the alphabet. X, Y, Z, you have an X and a Y, X and a Y. The first point is X1, Y1. The second point is X2, Y2. Okay, the third point would be X3, Y3 if we had a third point, but we don't need it. We only need 2 points. Okay, so you're trying to figure out the slope of these 2 points. So you have 2 points on a graph. Okay, so let's say, for instance, let me just draw something real quick so you can understand what this is really meaning. Let me see if I can draw something really quick. Da, 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 da. Okay. Okay, so let's say we had this really quick. Let me hurry up. I won't spend too much time on here. Okay, it's a little off, but let's say we have this, and let's say I have 2 points. Okay. Let's say I have a point here and a point here. Okay. And I'm trying to see how the point is slanted. You know, what's the slant of it? What's the steepness of it? Okay. And so I'm trying to figure out the ways, the steepness of it, the slant of it. Okay. So it was going upwards. Okay. So we know this is a positive slope. Okay, let me go through this. Okay, this is considered to be a positive slope because from left to right, you go from left to right. If a little stick person is here and they wind up here, they're going up the hill. Okay. So this is considered to be a positive slope. You always go from left to right like you read. So imagine yourself reading, looking on the left side, and then going to the right side. Are your eyes going up or are your eyes going down? And that's how you can tell if it's negative or positive. Okay, so I'll leave that alone. I'm not gonna go into too much because I still have a lot to cover. Um, Okay, so let me go through and erase this really quick. All right, so we have that. Okay, so we know it's a positive slope. Now, let's go through and plug it in. They say plug it in math. Sometimes they say substitute it. So I'm going to use the formula y2 minus y1 over x2 minus x1. Okay, I'm going to use that. I'm going to come up here and then I'm going to look. What is y2? Y2 is 13. So 13 is first minus what's y1? Y1 is 7. So 13 minus 7 over x2, which is 6, minus x1, which is 4. Okay? So I have this going on. So 13 minus 7 is what? Was 13 minus 7? 6 over 6 minus 4, which is 2. Okay. And so when you have a fraction, 6 over 2, that means 6 divided by 2. Fraction, so division. 6 divided by 2 is 3. So the answer for this is 3. The slope is 3. Okay. So when you have the slope formula, m equals, y2 minus y1 over x2 minus x1, or m equals delta y over delta x, once you go through and you solve it, you'll get your answer. And this is a positive 3. Okay, that's all you have to do. You have to go through, label your points, plug it in, and then do the math that comes with it. Okay, so what I'm going to do with this is erase this so we can go down to the next part. Okay, now let's see. Let's go to the quadratic formula. Recently, I did a video. Well, I did the video 2 years ago, but I uploaded it recently. So I did a whole video on the quadratic formula, the complex numbers, real numbers, imaginary numbers, and so on and so forth. So I did a whole video on this, and I'll leave it below. It was so much fun. I forgot I did it, and I saw it. I was like, wow, somebody might want to use this. So I went ahead, uploaded it. It's a very interesting video. I was very, very humorous. Okay, so quadratic formula. So you use the quadratic formula when you have a quadratic equation. Okay, so quadratic means when you have anytime you have x to the second power. Okay, x to the second power. That means a lot of times you're making a parabola. Okay, my parabola is looking kind of crazy, but it's like a point. It's like a point. Okay, you're making a parabola. And sometimes people call parabola, they call it parabola. It depends on your teacher, but most people call it a parabola. Okay, this whole thing. Okay, so a quadratic formula is when you use the x to the second power is in equations to create a parabola. Okay, now this right here, the formula. So what I'm gonna do first, right here, I'm gonna write down my equation. Let's say I have x to the second plus 5x plus 6 equals 0. Okay, so this is my quadratic equation. Okay, you see how I have x to the second? Okay, and it's in the form of ax squared plus bx plus c equals 0. That's the quadratic, that's the general equation. Now, the formula, I have it up here. It's a little, crazy to see up there, so I'm going to rewrite it. Let me erase this right here so I can have space because you need space for this. Woo, we need space. We about to start about to start having a lot of fun with this one. Okay. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's the formula. Okay, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, and you'll hear your teacher keep saying all over 2a. Okay, all right. Now, what is this a, b, and c stuff? What is that? Okay, so let's go back to the equation so we can get the a, b, and c. So the a, when you look at the top, the a is the number in front of the x squared. See that? So the number in front of the x squared here, if you don't see a number, is 1. Okay, so a is equal to 1. All right, so b, when you look up here, b is the number in front of the x. So the number in front of the x is 5. So you put a 5 here. And then C is the constant, okay? It's the number that just hanging off on the side. And if you don't see a number hanging off on the side, that means it's equal to 0. But in this case, the C is 6. So the answer is 6 for that. Now, if it was a subtract 6, then you make it a negative 6, okay? If it subtracts something, you have to make it a negative because it can either be positive or negative. Okay, so the first thing you do, you come over here, you figure out what your A, B, and C is, okay? And then you come over here and you plug it in. X equals negative B. So B is 5, so it's going to be negative 5 plus or minus. Oops, let me make this neat. So let me do this. Let me put in parentheses so you can be really safe. Okay, so you got negative, put the negative, and then whatever B is, put it in parentheses. Because sometimes the B is a negative, so you're going to say the negative of a negative, but eventually it'll be a positive, but just put in parentheses. Plus or minus, square root of, okay, B squared. So B squared, so B is 5, so I'm going to just put 5 to the second. Minus 4. I'm going to put times A. A is 1. And C is 6. Okay? All over 2 times what's A? 2 times 1. Okay. So first of all, you take the numbers and you plug it in to the same position that it's in already in the original equation. I mean, original formula. Okay, so now I'll go through and I'll work this out real quick. X equals negative 5. Okay, negative times 5 is negative 5 plus or minus square root of what you can do it manually, you can do it in a calculator. Right here, let's do this real quick. So 5 squared, that means 5 times 5. 5 times 5 is 25. Minus, and then you multiply these numbers together. 1 times 4, 4 times 1 times 6. So 4 times 1 is 4 times 6, is 24, but it's a minus, so it's minus 24 all over 2 times 1 is 2. Okay, so that's what we had thus far. Now, what I'm going to do is I'm going to come over here and say x equals negative 5 plus or minus square root of 25 minus 24 is 1 all over 2. Okay, and then I'm going to bring this over here and then I'm going to do x equals negative 5 square root of plus or minus. Okay. Square root of 1 is just 1. Okay. All over 2. Okay. So if I go and work this out, okay, I have it like this. Now, some teachers will accept it with it all together, the plus and the minus together, but sometimes teachers want to see 2 separate answers. So this is how you show the 2 separate answers. Okay. You show the plus and the minus one. So you have x equals negative 5 plus 1 over 2. And then you have x equals negative 5 minus 1 over 2. Okay, so x equals negative 5 plus 1. Okay, so negative 5 plus 1 is what? Negative 4 over 2. Okay, which is x equals negative 2. And then on this side, you have x equals negative 5 minus 1, which is negative 6 over 2. So right here, you have x equals negative 3. Negative 6, okay. Okay, so you have these. Now, the best thing to do, a lot of times, you can go ahead and plug it in real quick and see if it works. Or you can go through and do something, set it up like if you want to do like the FOIL method to check and see if you got it back. So what I'm going to do, since I don't have a lot of space, instead of doing the full method and checking it that way, what I'm going to do is come over here to the original formula. And I'm going to plug the numbers in to see if it works. Okay? I'm going to do it this way. So we have one answer. We have x equals negative 2. The other answer, we have x equals negative 3. I'm going to check in and see if both work. Okay? So x equals negative 2. I'm going to come over here and put negative 2 to the second power plus 5 times negative 2 plus 6 equals 0 and see if that works. Okay, so negative 2 to the second power means negative 2 times negative 2, which is 4. Plus 5 times negative 2, which is a negative 10, plus 6 equals 0. Let's see if that works. 4 minus negative 10, 4 minus 10, sorry, 4 minus 10 is negative 6, plus 6 is equal to 0. So 0 is equal to 0. So that works out. So we know that negative 2 definitely works out. Okay. Now what I'm going to do is erase it and then do negative 3. Okay. I'm gonna erase this. And if you're looking at the video, of course, you can rewind it, but I just need this space. So now what I'm going to do is put in negative 3 to the second power plus 5 times negative 3 plus 6 equals 0. Okay, I'm gonna see if this works. Okay, so -3 to the second power is 9. -3 times -3 is 9. Then you have 5 times -3, which is a -15. So 9 minus 15 plus 6 equals 0. 9 minus 15, which is -6 plus 6 equals 0. And so -6 plus 6 is 0, and that's equal to 0. So that checked out too. So yes, the answers are right. The answers are x equals to -2 and x equals to -3. When you're doing a quadratic equation, it's possible, of course, always possible to have two answers. Sometimes you have one unique answer, like you might have x equals 4, but it's really twice. Since it's a quadratic equation, it hits it twice. But for this one, we have two unique answers. Okay, we don't have one unique answer. We have two different answers for this one. Okay. And then sometimes you do the quadratic equation, you have imaginary numbers. When you have the square root of like a -1, the square root of a -2. Okay, and that's when you use the letter I for imaginary and things like that. But this one, this one is pretty simple, and it's not simple. Well, I'm not gonna say simple for everyone, but this one is I would say a general one. Okay, now some things like the SAT, you might have to do complex numbers, but for the GED, more than likely you don't. So this one will be general across the board. So what I'm going to do is erase this. Okay. And also, again, like I said, I went through the quadratic equation thoroughly with all the different types of problems in my video, and I'll have it below. Okay. So let's move on. Now, what we're going to talk about is the distance formula. Okay. Now, sometimes you have like a graph. So let me just draw this real quick, show you illustration. Okay. Sometimes you have a graph. Okay. That's the x-axis. That's the y-axis, a little slanted. Okay. And let's say you have 2 points. Let's say, for instance, I'm just put 2 random points. So you have a point here. Oops. Let's say, I don't want that. Let's say you have a point here, and let's say you have a point here. Okay. And you have to find the distance between the 2 points. So you're trying to find the distance between 2 points. Now, if the points are are lateral, are not lateral, but lateral or are vertical up and down, then you can count the spaces to find the distance. If the points are horizontal to each other, you can count across to find the distance. But if the points are on the diagonal, you have to use this formula to find the distance. Okay. And this formula comes from something called the Pythagorean Theorem and things like that. We'll get into that later on, but this is the formula that you use. So I'm going to rewrite the formula so you can see how it should look for the distance formula. Okay, so you'll see D equals square root of, okay, x sub 2 minus x sub 1 to the second power plus y sub 2 minus y sub 1 to the second power. Okay. And then sometimes in the distance formula, you might see x sub 1 minus x sub 2 squared, and then, y sub 1 minus y sub 2 squared. Okay. When you square it, it's going to make it positive because you're squaring it. So it doesn't really matter. As long as if you have the 2's first, x2, y2, and then you have the 1 second, as long as you have whatever number you're using in the right order, it doesn't matter. Okay. So let's go back up here and label it. X1, Y1, X2, Y2. Okay, so you always label your points. Remember, the first point is X1, Y1. The second point is X2, Y2. Okay. So we're going to stick to that. Sometimes you can switch it around and say, but let's stick to this right now so you can have an order of how you want things to be, how it should be. All right, so now what we're going to do is plug in the numbers. Okay, we're going to plug them in. Now in the parentheses, the x2 minus x1, so x2 is 2 minus x1, which is -2 squared, plus y2, which is 1 minus y1, which is 4. Okay. Now I will advise you, after you put the numbers in, go back real quick and see. X2 is 2 minus x1 minus a -2, and then you have y2, which is 1 minus y1, which is 4. You go back and you check it, because if you go through and do all of it, you got one thing wrong, the whole thing more than likely is going to be wrong. Okay. So the distance is equal to These two right here, let's say negative times a negative is a positive. So what you have is a 2 plus 2 to the second power plus a 1 minus 4 to the second power. Okay, so D is equal to 2 plus 2 is 4, so that's 4 to the second power plus 1 minus 4, which is negative 3 to the second power. Okay, so we come down here, we have 4 squared, which is 16, plus 3, negative 3 times negative 3, which is 9. Okay, and then you have D equals the square root of 16 plus 9, which is what? 25. And then what's the square root of 25? What number times itself gives you 25? So D is equal to 5, because 5 times 5 is 25. Remember, there's an imaginary 2 there. So you're looking for a twin. What number has a twin of 25? Is 5. So the distance between these two numbers here is 5 spaces, but it's diagonally. 5 spaces diagonally. And that's how you do the distance, okay? That's a good example of how you do the distance formula. All right, so I'm going to erase this one because we have more to come. Oh my goodness. Okay. All right, let's go next. The midpoint formula. Okay. So sometimes you have something, let me make it make sense. Sometimes you have a graph, okay? And of course, if you want to, you can label it X. This right here is the Y-axis. This is the X-axis I'm doing. And I'll label it real quick. So I always tell my students to label it. It's just that my time is really short. And I'm trying to give you everything I can give you within a certain amount of time. Okay, so you label it. That's X and the Y-axis, okay? Now, let's say, for instance, we have 2 points. So you can see why this makes sense. What you need this for? Let's say you have a point here. And let's say you have a point here. Okay? And let's say you're trying to find the midpoint. What does that mean? Midpoint. Midpoint means you're trying to find the point that's in the middle. Okay. So if you had these 2 points, you're trying to find a point that's probably somewhere. Let's see if I had to see somewhere here. Whee! Okay. I want to make it this. So let's say you're trying to find a point somewhere here. Okay, that's about midway, somewhere. Okay, so you're trying to find the midpoint. Okay, you're trying to find the point that's in the middle. You're somewhere, your friend is somewhere. Where do you meet? In the middle. You know, with the GPS and everything, they can do that. Okay, but here in math, this is how we do it. All right, so the first thing you do, you always start up with the equation. With the formula. So let me go through and get this. Okay, so the midpoint formula, we put it up here, but I'm going to write it out this way. Okay, so we're going to say the midpoint formula. Okay, so you're going to say x1, yeah, x1 plus x2, okay, over 2. Oh, let me make it neater. I'm sorry. Let me get it somewhat neat. Okay, let's do this real quick. Okay, let me do it. Okay, all right, we're going to say the midpoint. Okay, the midpoint is equal to, we're going to say x1 plus x2 all over 2, comma, we're going to say y1 plus y2 all over 2. Okay, so basically, if you look at this, you're trying to find the average of the x's and then the average of the y's, and then that would be the midpoint. Okay, you're trying to find something in the middle. You're trying to pretty much split it in half. And the way you split things in half is finding the average of whatever you have. Okay, if that makes sense. All right, so let's go through and label this really quick. X1, Y1, X2, Y2. Okay, so we're going to plug it in. Oops. Y2. Sorry. Oops. Let me fix that really quick. I am sorry. I apologize. I'm not sorry, but I apologize. Okay. So we come over here and we plug it in. So x1 is -1 plus x2 is 7 over 2. The second one is y1, which is 4, plus y2, which is 2, over 2. Okay, so this is what we have. And of course, they put it like this because it's a point. Okay, so you go and do the first one. -1 plus 7 is 6 over 2. And then you do 4 plus 2, which is also 6 over 2. And then you break it down. 6 divided by 2 is 3. 6 divided by 2 is 3. So the midpoint is 3, 3. 3, 3. Okay, 3 comma 3. Okay. So between the point -1, 4 and 7, 2 is 3, 3. Okay, so that's how you find the midpoint. You can always go back and double check and make sure you did everything right. You labeled it correctly. X1, -1, X2, 7, Y1, 4 plus y2 is 2, and then you do 6 over 2, 6 over 2, yes, and then you know it's right. I always go over my problems and double check. That's just something I do. I don't want to get anything wrong, so I always double check, because sometimes I'm thinking faster than I'm writing, so I have to always double check. All right, so what I'm going to do is erase this, and let's keep going. Now, the next thing I want to do is we're going to talk about factoring. Okay, factoring is very important and it's so much fun. Okay, so factoring common patterns. Okay, factoring. Pretty much factoring is like a form of division. You're taking an equation and you're breaking it down into parts. Sometimes the parts look the same, sometimes they look different, but it's a way, think of it as division. You're taking an equation and you're breaking it down to something that when you go backwards, you can multiply to get it again. Okay. So factoring is like you breaking it down, you factoring into it the parts, into its parts. All right. So the difference of squares. Very interesting. All right, so let's see. We have, okay, I already have the equation down. 25x squared minus 81. The difference means subtraction. Squares like something to the second power. Okay, so 2 square is what? The 2 square is 4. 3 square is 9. You know, 2 square means 2 times 2. 3 square means 3 times 3. Okay. Oh, sorry, 3 times 2. I said 3 times 3 and put 3 times 2. So 3 square means 3 times 3. Okay. 4 square is what? 4 square would be 16. 5 square would be what? 5 square would be 25. 8 square would be what? 8 square would be 64. 8 times 8 is 64. So that's what they mean when they say squares. Okay. So right here, when they said the difference of squares, in this case, they want you to find the square root. So let's go backwards. Okay, so let's say, what's the square root of 64? You're going to say, oh, that's 8. What's the square root of 25? Oh, that's 5. What's the square root of 64? Oh, that's 4. We're going backwards. What's the square root of 9? Square root of 9? Oh, that's 3. Okay, so we're looking for the square root of it when we find the difference of the squared. Okay, the number that has already been squared. So when we're trying to do this, like I said, 25x squared minus 18. When you factor, you want to have a set, of parentheses. Okay, a set. You want to have 2 parentheses for this type of factoring. Then you want to break it down to what twin times itself. Now this says difference. Since it said difference, we're not going to have, the thing that's going to be different is the sign. It's not going to be a positive and positive. The thing that's going to be different is the sign, because it says the difference. Okay. So in order to get the difference in math, you're doing different signs. The difference. Now the squares. What is the square root of 25? The square root of 25 is 5, and you put a 5. And then what's the square root of x squared? It's x, because x times x give you x squared back, okay? So you're doing the square root of 25x squared, which will be 5x times 5x. 5x times 5x is 25x squared, okay? And I'll show you this really quick. Okay, so 5x times 5x equals 25. And then x to the first times x to the first is x to the second. And I'll go over that later when I talk about exponents, okay? So we get the 25x squared back when we multiplied it. And then what's the square root of 81? What number times itself? What twin give you 81? 9 times 9 is 81, okay? So that's how you break that down, okay? That's how you break that down. And if you want to check it, I'll take a moment to go through it real quick and show you how you can check it. Let me hurry up and go through this. All right, we're going to do something called the FOIL method. So I'll go through that really quick for you so that we can check. We're going to check to see if we get this back, okay? That's the only reason we're checking, to see if we get the original expression back, okay? So the first thing you do for the FOIL method to check it Let me do this really quick. Foil, like aluminum foil. The first thing you do is first, F stand for first, the first terms, which is 5x times 5x. 5x times 5x is 25x squared. Then you do the outermost, the ones that's on the outside. Okay, you do the outer, and that would be 5x times negative 9. 5x times negative 9, which would be negative 45x. And then you do the innermost, the ones that's touching on the inside. So they call this the inner. The innermost would be this, 9 times 5x. 9 times 5x, I'll put it here. 9 times 5x, which equals 45x. And then you do the last. L stand for last. Okay. The last one's in the parentheses is 9 times negative 9. So you say 9 times negative 9, which is equal to a negative 81. Okay, and when you look at this, you'll see that the inner ones cancel out. A negative 45x and a positive 45x cancel out. And so you bring these down and you'll get 25x squared minus 81. Okay, so when you go and you look, it's the same thing. So that means that your answer is correct. Okay, so I wasn't expecting to do the FOIL method, but why not? Okay, so that's the FOIL method for you to check to make sure your difference of squares are your difference of squares correct. All right, so let's keep it moving. All right, delete everything. Okay. All right, let's go down to the perfect square trinomial. So, of course, it's called a trinomial when you have the first thing we did before at the top. This is called a binomial because there's two terms, okay? I'll discuss that. That's binomial because it's two. Bi means two, like bicycle and things like that. Now we go into trinomials. That means that it's three terms, like tricycle and things like that. So let's go ahead. So we perfect trinomial. So I'm gonna rewrite this as x to the second plus 10x plus 25. Okay, so we're trying to factor this pretty much, like I said, it's like a form of division with variables, if you want to look at it that way. So we're trying to find the perfect square trinomial. So this one, we're trying to find a perfect square. That means that we're trying to find a twin, a set of twins, dealing with these variables, okay? So the way you would read this, so let me put it over here because I'm going to show you how to read it because that's just the easiest way for me. You read it backwards. You're looking for two numbers that you multiply to get 25, okay? But when you add them, you get 10, okay? So you multiply to get 25, but when you add them, you get 10. So you come over here and figure out what are the multiples of 25. You can say, okay, 25 and 1. 5 and 5. Now, any of these, when you add them, do you get 10? This is 26. When you add this, you get 10. You see that? So the two numbers we're looking for is 5 and 5. You see that? 5 and 5. So what we do, we come over here with the parentheses, and you do x, and you do x. Okay, you do x and x because remember, you're trying to break them down evenly. Okay, so the square root of x squared is x. So x times x give you x squared back. You want to be able to multiply it to get it back. Okay, and then you have a plus sign. Okay, when you have a plus sign, you want to use the same as whatever this one is. Okay, so you're going to have two plus signs. Versus if you have a subtraction here, then it would be different signs at the end, different signs. So we use plus and plus, and then we use 5 and 5. Okay? And so the answer would be x plus 5, x plus 5. X plus 5 times x plus 5. Well, sometimes they write it like this. Okay? Now, if you want to go through and check it, we can do it again. FOIL. Okay, we can do it again really quick. Okay, so the first x times x is x squared. Outer x times 5 is 5x. Inner 5 times x is 5x. Last 5 times 5 is 25. And then you add these two, and so you get x squared, you bring that down, plus 10x, because this right here is equal to 10x, plus 25. and then you check it and see if it's the same, and voila, you know it's right. Okay. So I might do a video on factoring one day. It's so much fun, so I might do that one day. All right, so that's enough with that factoring. Let me erase that one. And let's go to the next one. All right. So the next problem is perfect square trinomial. All right, so this one is very similar to the last one. However, this one has a subtraction sign in here. So it's a slight difference. So you have x squared minus 18x plus 81. Okay, same concept. You're looking for two numbers when you multiply to get 81, but when you add them, you get 18. Okay, two numbers you multiply to get 81, when you add them, you get 18. So you come over here and find the multiples of 81. 81 and 1, 9 and 9. You can say what, 3 and 27? Yeah, okay. And we can stop there. So which ones, when you add them, you get 18. So this one will be 82, this one will be 18, and then this one will be 30. So you know it's going to be 9 and 9. Okay, and look, you're looking for the perfect square, so it has to be a twin. Okay, so you come over here, you do your parentheses, you do your x and the x, because remember you'll be dividing it. One x and one x and the other. It has to be a twin. You have a plus sign, but remember you have to have two of the same, whatever the first sign is. So you know the signs are going to be subtraction. And then 81, you know, is 9 and 9. So when you factor this, x squared minus 18x plus 81, you get x minus 9 to the second power. Okay. And if you want to check it, why not? We've been checking it before. Let's go through and have some fun doing the FOIL method. And there's another method also to do it. Let's see. Should I show you the other method? Okay, I'll show you the other method. This is another method you can do to multiply also. So let's see if you like this. I learned this in college and it was amazing. Okay, so you can multiply like this. Just like you multiply regular numbers, you can multiply this like right here. So let's say this. Let's say, so the first thing you do, what is -9 times -9? Okay, I'm doing the colors. Okay, so that's going to be a positive 81. And then I'll go back to yellow again. And then what is -9 times x? Okay, and then that would be negative 9x. Okay, and then in math, you put the placeholder down. And then let me get a different color. What is x times -9? Okay, let me make it green again. That will be negative 9x. And then let me make it red again. What is x times x? Okay, make it green again. And that is x to the second power. Oh, I meant to make it green. Let me just go in order. Make it green. Let me make sure everything is still plugged in. Okay. Oh, yeah, because to make sure everything's still plugged in. If I go through doing everything is not plugged in, it'll be crazy. Okay. Okay, and that'll be x to the second power. Okay, you go and combine like terms. That'll be 81 plus, that'll be negative 18x, and that'll be x squared. And if you go and you check, bam, you got the same answer back. Okay, so instead of doing a FOIL method, you can go through and do multiplication, the way we multiply multi-digit numbers. So I learned this way in college. It was so amazing. So you can do the FOIL method. You can do it this way. They have a method called the box method. They have so many ways to do this problem. Okay. So what I'm going to do, we're going to go to the next problem. And of course, like I said, you can always slow this down. I just want to make sure I cover all this content, which is a lot. All right. But it's fun, so no one's complaining. It is fun. All right, so the next thing, let me get a different color. Let's do red. All right, so we're trying to find the perimeter. We're going to geometry, geometry. Okay, when I met my husband, I was teaching geometry. He was teaching geometry. We were geometry high school teachers, right? So yeah, geometry is so interesting. I used to have this complete board. My whole wall was like a board. And I would make all these three-dimensional figures. It was so much fun. My students thought I was doing too much, but it was so much fun. Okay, let's get back to it. All right, so geometry. We're gonna talk about perimeter. So the perimeter is when you add all the sides of a shape, whether it's a triangle, rectangle, trapezoid, whatever. You add all the sides. So for this one, I decided to make this 3, make this 4, and make this 5. So we have 3, 4, and 5. To find the perimeter, you have to add. So you add 3 plus 4 plus 5. And what do you get? What do you get? You get 12. Okay, 12. And don't forget the units. Okay, 3 millimeters plus 4 millimeters plus 5 millimeters equals what? Equals what? Equals what? 12 millimeters. Okay, so the units are extremely important. They just take off if you don't have the right units because it could be anything. Okay. But if you don't have units, they normally say units, 3 units plus 4 units plus 5 units is 12 units, okay? All right, so we have that. Very nice. Perimeter means add all the sides. And in math, they might say sides or they might say edges. Side is synonymous with edges. It means the same thing in math, okay? All right, so let's go down. All right, so we're looking at the area formula. So the area is the square units inside a shape. It's the squares inside of the shape, the square units inside of the shape. So when we find the area, what do? We're multiplying. We're multiplying. Okay. Multiplying. Okay, so for this, I said the length was 3 cms, 3 centimeters, and I said the width was 9 cms, 9 centimeters. So imagine this. I'm gonna just draw it out real quick so we can see how it looked back in elementary school. All right, so let's see. Let's break this up into 9. Let's say this is 1. Oops. Let me make it straight. Let me at least try to make it straight. Okay, I'm gonna break this up in squares for you really quick, really quick, really quick. We're gonna make 9 squares real quick. 9 squares, not squares, but 9 lines. Okay, I'm trying to make it even, trying to make it even, trying to make it even. Okay, so let's imagine 9 being across 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's make it 3 across. Sometimes you don't have this, but when you're in elementary school, some people are used to saying it like this. So what I'm gonna do, I'm breaking it down in squares. Okay, imagine squares. So area are the square units. You breaking the shape into square units. So that's what I just did. And pretty much what they normally do, they will go through and count them. But we can quickly do them by multiplying. So we just multiply 3 centimeters times 9 centimeters. And guess what? We get 27 squared centimeters. We say square centimeters, but some people say centimeter square. But when you go to like Home Depot, Lowe's, and things like that, when you ask them for like carpet, you want to say square units because these are square units. Okay, these are square units. Okay. Okay. All right. So I'm gonna erase that. That's it for that one. And let's go to the next one. All right, let's go down. Let's go down. All right, so now we actually have a square. We talk about square units, but we have a square. So you can for this one we set 4. Okay, I said 4. So I said that the side is equal to 4 meters. Okay, so the formula here, and I ain't talking about the formula above. Sorry, I ain't talking about the formula above. Let me go back. So the formula above for this, yeah, it was the length times the width. Sorry, I ain't talk about that. You multiply the length times the width. This is what L stand for. Sorry, the length times the width. Okay, that was that. And then the one on top, let me go back. Okay, yeah, you okay with that one? Okay. Okay, I'm sorry. Let me go back. Okay. Just in case anybody forgot. Okay, so for the square, like I said, the square we said 4 meters. Okay, so 4 meters. The side of the square is 4 meters. So that's 4 meters here, 4 meters here, 4 meters here, or 4 meters here. Okay. So around the whole square is 4 meters. However, if you're trying to find the area of a square, you just multiply the side squared. Okay. Side squared. So you say 4 to the second power, which is 4 times 4, which is 16. Okay. And you can use the same formula for a rectangle. The rectangle was length times width. You know, this is the length and that's the width. So you still get 16. Okay. 16 square meters. Okay. And so that's it. You just multiply. And remember, it's the same thing. You got 4 going down and you got 4 going across. And you count the squares and you're going to get 16. 16 square meters inside of the square. Okay, and that's how you do the area of a shape. Okay, let me clear that out. Let's go to the next one. Are we getting there? All right, so for a triangle, you have the area is equal to half the base times the height. Okay, so for the triangle, they gave us a base, they gave us a height. Okay, so let's see. So triangles are half the base times the height. I said that the base is 2, so let's make this 2 feet. And I said the height is 3, so let's make that 3 feet. Okay. And so the formula says A equals 1/2 the base times the height. Okay, there's different formulas for this. Some of them have base times height over 2, the same thing. Okay, so A is equal to half times the base, which is 2, times the height, which is 3. And if you interchange and put 3 times 2, you still get the same thing. And multiplication, if you flip the numbers around, you can still get the same answer. Okay, it's commutative. All right, so A is equal to 1/2 of 2 times 3. So 1/2 of 2 is 1 times 3 is 3. And so the units are feet, so it's 3 square feet. Okay, so because it's 2 feet times 3 feet, which is 3 square feet. So that's the answer for the triangle. And the reason, do you know the reason that is 1/2 base times the height? Do you know? Do you know? Do you know? Okay, because let's see. I'm gonna draw as much as possible that I can draw it. Might be off a little bit. Let's say this is the same triangle, okay? Let's say this is the same triangle. Did my best. It's a little off. Oops, let me erase that. Let me try to make it neat without using the tool. Let's see, let's see. I was doing a lot earlier. A little bit tired, but I'm going to push through. Oops, almost. Okay, so it's a half because let's say, for instance, you have 3. Let's say, for instance, you had 3 and okay, you got 3, 2. Okay, let's say you have like this. Let's say you got 3 and 2 here. Okay, 3 and 2 here, right? Now let's say we're doing this. Let's say this is a rectangle, of course, and we multiply. Let's say we wanted to find the area of this rectangle. Remember, the area of the rectangle is A equals the length times the width. So you multiply 3 times 2, and guess what you get? You get 6, okay? But a triangle is half of it. Uh-huh. That's why the answer is not 6, it's 3. Okay, because the triangle is half of the rectangle. That's where the formula, the 1/2 the base times the height. Instead of saying the length times the width, they say 1/2 the base times the height. Well, you could have did 1/2 the length times the width. Pretty much the same thing. Okay, just a little thing I decided to throw in there. Uh-huh. All right. Let's go to the next one. We're getting there. We're getting there. We're getting there. Okay, now we're dealing with the wonderful circles. The wonderful circles. Okay, so the area of a circle. Okay, the area is equal to pi r to the second power. Okay, so let me write this. A equals pi r squared. That's what they say, r squared. Okay, A equals pi r squared. In a circle, we have a unit. This is a Greek alphabet called pi, which is 3.14 rounded, but it's normally 3.14159, and it goes on infinitely. Okay, but we tend to round it so we can use it to get the answer really quick. But if you have a calculator and if you use it in a calculator. You can still multiply the numbers, and at the end you can round it, okay? Because this is called an irrational number. That means it goes on without repeating, okay? It goes on continuously and it doesn't repeat. So pi is the irrational number. So in math, we round it. Or some teachers might tell you to use the pi symbol and then at the end round it. So it depends on what the instructions are. So for right now, we're going to use 3.14. And I said the radius is 10. So let's look at this really quick. What is the radius? Where is the radius? So when you look at the circle, right? From the center to the circle, halfway, that's called the radius, okay? That is called the radius. That's the radius, that's equal to 10. However, let's say the line goes all the way through. If it goes all the way through, then that's called the diameter. Okay, so the diameter is 20 because it's two of them. Okay, it takes two radii to make one diameter. So the radius is 10, where the diameter is 20. Okay, that's just something to just to know. I erase that one. Okay, so the radius is 10 in this situation, so we just plug it in just to do the work. Okay, so I said that A is equal to pi r squared. Okay, so A is equal to 3.14 times the radius, which is 10 to the second power. Okay, so what we do now is something called the order of operation. You have multiplication, then you have exponents. But like order of operation is parentheses first, then you have exponents, like something to the second power, something to the third power, whatever. Then you have multiplication or division, whatever one comes first from left to right. Then you have addition or subtraction, whatever one comes first from left to right. So in this case, we have multiplication and we have exponents. Exponents are first. And so 10 squared is 100. And then you got 3.14 times 100, okay? And then the units, did I put units? I didn't put units on this. Okay, we'll just say units. And so 3.14 times 100, and we multiply something times 100, has two zeros, so you move it two spaces to the right. Bam, bam. So the answer is 3.14, okay? Answer is 3.14, let's say square units, okay? Since I don't have any particular units, I'll just say square units. Okay. So when you multiply something by 100, you move it over two decimal points. If you multiply something by 10, you move it over one decimal point. You move it over the amount of zeros you have. Okay, so that's another little trick if you like it. All right, let's clear that out. All right, let's move it, keep it moving, keep it moving. All right, trapezoid. Okay, so we have a trapezoid going on here. All right, so the formula for the trapezoid, okay, we have A equals 1/2 the height, okay, base 1 plus base 2. Okay, so I'm gonna rewrite it again. A equals 1/2 the height, base 1 plus base 2. Now, sometimes you might see that A is equal to the height times the quantity of B1 plus B2 all over 2. It's the same formula. It's the same formula, okay? Now, for this right here, I said that the height was 15. I said the base 1 was 16. I said the base 2 was 18, okay? Now, I have to see if you need to round it. So I will see that as we go through it. That's 18. But what we're going to do right now is plug it in. So A equals 1/2. We said the height is 15 times the quantity of 16 plus 18. Okay? So A is 1/2 of 15. We can say 7.5 times the quantity of 16 plus 18. So we say that is 34. Okay. And so you just multiply 34 times 7 point do that really quick so we keep moving. You do 34. 34 times 7.5. And then you get your answer. Okay. Which is 255. Did I use units? No. So answer would be 255 and they make it neat. So the area of this would be 255. Okay. So that's for that. That's for the trapezoid. 255 or 255. 255, let's say square units. Sorry. Okay. All right, so that's done. Let's clear this out. And you see the 1/2 there. You know why the 1/2 is there, right? What formula has 1/2 in it? That triangle. Okay. The triangle has the 1/2 in it. All right, so let's clear this out. All right, let's keep it moving. All right, so now we're looking for this. Now we're looking for the circumference. So circles do not have sides or edges. Circles have arcs. Okay, the little pieces that make a circle are called arcs. Okay, so we don't say perimeter since we don't have sides and we don't have sides and we don't have edges. We say circumference. The distance around is the circumference because it's a circle. It have arcs. Okay, it's circular. Okay, have arcs. So the circumference is defining the distance around the circle. So let's get started. So we have two formulas. We have C equals the circumference equals 2 times pi r, and or we have C equals pi d. Okay, so again, let me go through and do this really quick. Okay, so remember I said the radius is the segment, the line segment from the center to the circle. Okay, that's the radius. So the radius is equal to 6. See, all right here, 6. And radius is equal to 6. Now you see you have two formulas right here. So to get the diameter, what did I say about the diameter before? Okay, we said the diameter is the length from circle to circle. It's the complete one. Okay, so the diameter is what? The diameter is going to be 12. Okay, so D equals 12. So D equals 12 because it's the line segment from circle to circle, or arc to arc, and then that splits the circle in half. And then the radius is the part from the center to the circle. Okay, so we'll just go ahead and plug these in really quick so you'll have that. Let me just do it this way. Okay, so the circumference is equal to 2 pi times r. We said r is 6. Okay, so C equals 2 is a 3.14 times 6. All right, so we'll do that really quick. Let me do that really fast. We'll say 3.14 times 2 times 6. Okay, so 37.68. Okay, 37.68. We'll say, yeah, 37.68 units because we're not trying to find the area. We're just looking for the distance. It's just the length. Okay. And then we do this one over here. C equals pi, or we can just say 3.14 times D, which is 12. And if you see, you will get the same answer. So C is equal to 37.68 units. Put S on there. Okay, units. Okay, and so this is rounded. This is already rounded to the second power. I mean, not second power, the second decimal value, or the hundreds place. Righty. So that's good. And let's move on to the next one. Let me clear this out. And let's go down. We'll go up here. All right, so now we're doing the volume. The volume formula, we're looking for a rectangular prism. So this is a rectangular prism. This is like a three-dimensional figure. It's a rectangle, 3 dimensions. And so if you look at the example that I put down for this, I put the length is 4, the width is 12, and the height is 8. So I'm just gonna do that. Okay, so I said the length is 4. I said the width, I'll put this down. The width is 12. And then I said the height is 8. Okay, so this is the 3 dimensions, the 4 by 8 by 12. Okay, so when you're looking at the formula, it says the volume of a rectangular prism is the length times the width times the height. Okay, that's how you find the volume of a rectangular prism. So only thing we have to do is multiply. Multiply 4 times 8 times 12. And remember, when it comes to this, there's no certain numbers you have to multiply in any particular order, because multiplication, you still get the answer regardless of what you multiply. It's a commutative, so um it doesn't matter what you multiply first. So, 4 times 8, you already know that's 34. I mean, 32. So you got 4 times 8 times 12. So that's 12 times 32. Okay, so I got 384. So the volume is equal to 384. Okay, 384 cubic inches to the third power. So since it's a cube, it's called cubic inches, or three-dimensional, okay? Cubic inches and make a three-dimensional figure. Okay. So yeah, that's how you do for that. For volume is to the third power, cubic, okay. Cubic inches is three-dimensional. Okay, so I'll just go through and erase that. I'm gonna keep going. Okay, now we're talking about a cylinder. An example of a cylinder will be a can, a soda can. Okay, so I'm gonna go through and I'm gonna put down everything I have from here. So 10, I said, was the height, and I said that the radius, okay, is 5. And did I use, okay, and I said the radius is 5. Okay, so this is the formula for the cylinder. The cylinder is the volume equals pi radius square h, okay? Pi radius square h. So pretty much what this is, you find the area of the circle. You see how it has pi r square, and then you multiply it by the height. So you take the area of the circle and you multiply it by the height so you can get the cylinder, okay? That's how it works. All right, so let's plug it in. 3.14 times r, which is the radius, which is 5, times r squared times 10. Don't forget the square, because if you do forget the square, your answer will come out incorrect. Okay, so as I do it right here, you can do it too with me. 3.14. Okay. 20. Okay, so for the answer, I got 700. V equals 785. It would be cubic units, so I'm gonna say units cubed. Okay, but it would be cubic units. Okay, cubic units. Okay, so if it was feet, it'd be cubic feet. If it was inches, cubic inches, but we doing volume. Volume is three-dimensional, so it's going to be cubic. Okay, so I will clear that out. All right, let's keep it moving. Let's see what's next. Okay, the Pythagorean theorem. The Pythagorean theorem for right triangles. Okay, let's get ready. Let's get ready to rumble. Okay. All right. All right, so the Pythagorean theorem. Okay, so a square plus b square equals c squared. A square plus b square equals c squared. All right, so let's get back on track. All right, so when you look at my example, I said that A is 3 and B is 4. So A is 3. So A tends to be the smallest side, but it doesn't have to be. A and B can be interchanged, only A and B, not C. Okay. So B is equal to 4. And then C is the question mark. Okay, we don't know what C is. So that's supposed to be a question mark, y'all. Hang in there with me. That's a question mark. My hand's getting a little bit tired. Okay, so A, B, and C. So in math, the Pythagorean theorem is like, you have a right triangle. It's a right triangle because this is a right angle right here. This means 90 degrees. Okay, so it makes a perfect corner. Okay, a perfect corner, perfect L. Okay, so you have A square. So the two legs, they call legs. The two legs that's touching the right angle, when you square a squared plus b squared, you get c squared. That's the formula. They figure it out and it always works. Okay. So this one plus this one squared plus that one squared equals this one squared. Okay. Very genius. It was figured out. So what we're going to do, we're going to find out what c is equal to. So this is how you do this one. Give you this really quick. So we have a squared plus b squared equals c squared. Okay, so a is 3. And remember, I said you can interchange A. If you put 3 there and B, and if you mix it up, it would still be cool. But I put 3 here because 3 is smaller, and that's the smaller leg or the smaller side. So 3 squared plus 4 squared. I put 3 here because 3 is A. I put 4 here because 4 is B, equals C squared. Okay. So 3 to the second power is 3 times 3, which is 9. Plus 4 to the second power is 4 times 4, which is 16, equals C squared. All right, 9 plus 16 equals 25, equals C squared. Now, in order to get C, we have to get C by itself. It's not by itself, it's with a square. So the opposite of squared in math is the square root. So we take the square root of both sides. So there's an imaginary 2 there and imaginary 2 there. Okay? When we do this, the square and the square root cancels out and it brings out the C. And the square root of 25, remember, this means twin. What has a twin that's when you multiply, you get 25? You already know. You already know. It's 5. Okay? So 5 equals C, or C equals 5. Let me put that right here. Okay. So when you have 3 squared plus 4 squared, you get 5 squared, but when you take the square root of it, you get 5 back. So if one side is 3, the other side is 4, the other side is going to be 5. And let's call it the Pythagorean triples. There's certain numbers, 3, 4, 5, and other numbers that you'll see memorized. You have those memorized for the Pythagorean theorem. Okay, I just did 3, 4, and 5 because that's like the easiest one that I can remember. All right, so I'm going to go through and clear this one out. All right, keep moving. And then there's more to the Pythagorean theorem. Sometimes you have to take the square root of it and do that. Find the perfect square root, exact digits and stuff like that. But I just picked something that would be similar to everyone, and that would be a basic one. All right, now some of the interior angles of a polygon. Okay, so you have triangles, squares, rectangles, you have pentagons and heptagons and nonagons and decagons. Okay, so we're looking for the inside sum of all the shapes. I mean, of any shape. Okay, so the inside of a triangle, I don't know if you remember, we didn't do that, but if you have a triangle, the inside of a triangle is 180. Okay, the inside of a square is 360. And I'll show you that real quick. I'll show you a square real quick so I can demonstrate that really fast. Okay, so let's say we have a square or rectangle. Let's say we have a rectangle, it doesn't matter. Okay, and we want to find how many degrees are inside. This is 90. This is 90. Put your degree symbol. This is 90. And this is 90. And 90 times 4 equals 360. Okay, so we have 360 degrees inside of a quadrilateral. Quad means 4. Squares, rectangles, trapezoids, kites, and things like that, So we have 360 degrees inside of there. And also, if you want to look at it like this, we have 2 triangles. If one triangle is 180, and the other one is 180, then 180 plus 180 is 360. Okay. So we're looking at a pentagon right here. This is 1, 2, 3, 4, 5 sides. Okay. And then some people like, well, I don't know. I mean, one thing you could do, you could make triangles if you wanted to figure that out. You could make triangles, and I'll show you that also, but let's use the formula. The formula for the interior angles of a polygon is or just different ways you can write. You can write n minus 2 times 180, or I have seen 180 times the quantity of n minus 2. Okay, so that's the formula right there. And let me make it straight so that when I do the work, you will see it. I'm going to say 180 degrees times n minus 2. Okay, so n equals the number of sides. Okay, so we have a pentagon has 5 sides. So we do 180 times 5 minus 2, which is 180, okay, times 3. Okay, that's 180 times 3, which you will get 540. Okay, 180 times 3 is 540. Now, if you couldn't figure it out doing the formula, one thing you could do is you can make this into triangles. Okay, oops, let me make it straight. Okay, so that's 180. And then two triangles right here, that's 180, and then that's 180. Okay, so 180, 180, 180, you still get 540. Okay, so when you're doing polygons, you can either, make it into triangles with triangles that don't intercept, you know, or you can just use this formula, the quantity of n minus 2 times 180, and you can figure out how many degrees inside of a pentagon. So there's 540 degrees in the pentagon. Okay. Yeah, you can relate that to any type of polygon. It has to be a closed shape in order to be a polygon. Alrighty, so that's something. Let's finish that. Let's keep going. All right, special right triangles, trigonometry, sine, cosine, tangent, cosecant, cosine, cotangent. Bloop, bloop, bloop. Okay, all right. Let me get back on track. All right, now, special right triangles. It's called a special right triangle because it's a formula. It's just something that's always related, So, for instance, you got 45, 45, 90. Like I told you before, the inside of a triangle is equal to 180 degrees, okay? Now, this triangle is called an isosceles triangle. Isosceles means that at least two sides are the same, okay? At least two sides are the same. So let me say that because it gets a little deeper, but at least two sides are the same. I'm gonna say that. Now, this is an isosceles triangle. Is equal to 180. If these two sides are equal, they said when the sides are equal or the two legs are equal, the two angles are equal also. Okay, that's a law. I'm gonna say law of postulate in geometry. Okay, so if this is 90 and these two are equal, these must be 45. Okay. So this triangle is considered to be a 45, 45, 90 degree triangle. And when you have a 45, 45, 90 degree triangle, there's a formula that you can use to get the sides around the triangle. Okay. So it's telling you right here, you have X right here. So these two are the same. So both of those are going to be X. And then to get the C, which is this, the C is the side that's opposite the angle. This is called the hypotenuse. We didn't talk about that much with the other stuff, but this is called the hypotenuse. Okay, that's the longest side of a right triangle. Okay, so you have XX, and then this one you have X square root of 2. So when you talk about special triangles, so sometimes they call this A, they call this B, and they call this C. If you want to relate it back to A squared plus B squared equals C squared, okay? So A and B, like I said, can be interchanged, especially on this because they're the same length, okay? And the other ones they can also too. But that's A, that's B, and that's C. So A and B are going to be the same in an isosceles triangle, isosceles right triangle, because they're the same length. You can tell when they're the same length because they have the same congruent symbol. Okay. When the symbols are the same, that means that the lengths are the same in geometry, okay, or in math. All right. So we know that's the same. So that's why that's X and X. So for instance, if this was 6, then this would be 6. Okay, if that's 6, that's 6, so they the same. All right, so the tricky part is how do we get the C, which is the longest side of the triangle, which is called the hypotenuse. But let's do the example that I set up for you all here. All right, so let's say, for instance, bye-bye. Okay, so for here, I put the example X is 3. So this X is 3, and we said X is 3. Okay, so this is 3 and this is 3 because both sides are congruent. Now, to get the C, you have to multiply X times the square root of 2. Okay, so since X is 3, what is 3 times the square root of 2? It would just be 3 square root of 2. And so that's it for that one. Okay, that's all you do for that one. Yeah, so for the special right triangle, I might make a video on the special right triangle because there's so many things that I want to show you. But for this purpose of just doing the general one, this is all that's needed for everything that's common amongst all the different tests. So 3, 3, and then 3 square root of 2. Okay. All right, so let's get out of here. Let's go next. Now, another special right triangle is the 30, 60, 90 degree triangle. Okay. So 30, 60, 90 degree triangle is something called a scalenes right triangle in this case. Well, I'm going to call it scalenes, but it doesn't have to be 30, 60, 90, but it's 30, 60, 90 is a type of scalenes right triangle. Okay. It's a type. All right. So we have x square root of 3, and 2x. I'm going to put it here. We have x. Okay. X square root of 3. And then we have 2x. Okay, so we have x square root of 3, and 2x. And we said x is going to be 6. So this is 6. And then over here, you multiply 6 square root of 3. So 6 square root of 3. Okay. And then right here, you multiply by 2. So you say, what's 2 times 6? And that one is 12. Okay, so the answers are sorry, let me go back. Let me make it neater. So for this really quick, so you have 6 root 3, and you have 12 here, and then you have 6 here. Okay, so you have that. Let's say okay, so some people say, well, why is 6 times? Okay, so this is the reason that 6 times square root of 3. Okay, so remember, when you look at this, right? In front of the square root symbol is going to be a 1. There's an imaginary 1. So you multiply 6 times the 1 to get 6 square root of 3. Okay, so let's say, for instance, you didn't have 6. Let's say you had a square root of 2 times the square root of 3. Since they both are under the square roots, then that would be the square root of 6. Okay, because you multiplying a square root of 2 number times the square root of 3 number, which is the square root of 6. Okay, but this one, 6 is the whole number. So you multiply 6 times the whole number that's on the outside, and then you bring the square root down, just in case you have a question about that. Okay, and there's so much more I can go into this, but like I said, I might make a video about special right triangles because they're so fun. And then in the video, we might go back from how you go from the C, which is the hypotenuse, back to the A or back to the B, vice versa. Okay, so I might do that. I might do that. That sounds like a lot of fun. All right, so let me just get out of here. All right, and let's go down. All right, so now we're on data analysis, statistics, and probability. It sounds like it's a problem, right? All right, so I decided to use the numbers 1, 3, 4, 6, 6, 7, 8 to demonstrate how to do all these different well, these are going to be measure of central tendency. If you know anything about mean, median, mode, we call those measures of central tendency, how to get to the center of something in a way. Okay, so mean means the average. The average. So everyone remembers the average. You add all the numbers up, then you divide by the amount of numbers. Okay, so right here it says the sum of the value divided by the number of the value. Sum means the total. Okay. So you add 1 plus 3 plus 4 plus 6 plus 6 plus 7 plus 8. Okay, you add that up. Okay, so that's 4, 4 is 8. That's okay, 4, 4, that's 8. That's 16. Oh, sorry, 4, 4 is 8 plus 6 is 14 plus 6 more is 20. Then it's 27. Then is what? Then is what? Then is what? 35. Okay, so you have 35 over how many numbers? 1, 2, 3, 4, 5, 6, 7. So 35 over 7. And remember, when it's a fraction, you divide. What's 35 divided by 7? 5. Okay, so the mean, which is the average, is 5. Okay, the mean, which is the average, is 5. All right, so let's see if I'm missing anything. No, I think everything is good. Okay. So much more to do. Okay. So the mean, remember, the mean is when you take the sum of the values, but you add all the numbers up and you divide by the amount of value, number of the numbers, and divide by the amount of numbers. Okay. So I can keep this here. Let's do the median. Okay. So median, it says here, the middle value. Okay. So it's the middle value in the order set of data. Okay. So basically, you want to put the numbers in order from least to greatest. And I have already done that for you. You put the numbers in order from least to greatest first when you find the median so you can know which one is in the middle in that order. Okay. Now, so for this one, we have 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to have one number in the middle because 7 is an odd number. So I'm going to just write the numbers out and let you see me do this in real time. Okay, people tend to cross out the numbers on the end till they get to the numbers in the middle. So 6 is the median. Okay, so the median equals 6. Okay, now sometimes you do have an even amount of numbers in the middle. So let's say you had 1, 3, 4. Let's say you had 4 again, 6, 6, 7, 8. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers. So we have 8 numbers. That means if we divide it, it's going to be divided with 2. It's going to be divided in the middle. Okay, with 2 sets of numbers on the end. So let's do that. We cancel that out. We cancel that out. We cancel this. Cancel this. Cancel this. Cancel this. And guess what? We have 2 numbers in the middle instead of just having one like here. When you have 2 numbers in the middle, you have to figure out what the number is in the middle. You can look at it and say, okay, I got 4 and 6, so the number in the middle must be 5. Sometimes you can look at it, but if you can't look at it and figure it out, you can go ahead and take the 2 numbers, the 4 and the 6. You can add them up and divide it by 2. You're taking the average. Remember in the beginning, I talked to you about when you take the average, you get what's in the middle when we did the midpoint. So 4 plus 6 is 10, and 10 divided by 2 is 5. So you still get 5 for the median, no matter if you're able to look at it or you just take the 2 numbers and divide it by 2. Okay, we got that. Now I want to go to the mode. Okay, let me clear this out real quick. All right, let's go down to the mode. Okay. All right, so the mode is the number that you see the most, the most frequent, okay? The number that you see the most. So only thing you have to do is look at the data set and say, ooh, I see 6 the most. So 6 is the mode. Now, if you don't see any numbers the most, let's say you have 1, 2, 3, 4. You don't write 0, you write none or no mode. Some people make a mistake with that. They put 0. Okay, no, you don't put 0 because 0 could actually be a mode. It can be 0, 0, 0, 1, 2, 3, 4, you know. So this is none or no mode. Okay. Now range is telling you about the range. The range is the highest value minus the lowest value. So you look at the numbers in order from least to greatest. The highest number is 8 minus the lowest number is 1. So the range, which is the spread of numbers, is 7. The range is 7. You take the highest value, or sometimes they say the maximum minus the minimum. If you're talking about quartiles, if you're talking about box and whiskers and things like that. Okay, so it's 7. All righty. Let's see what's next. All right, let me erase this, clear this out. All right, so I decided to do a quick probability problem. So the number of favorable outcomes divided by the total number of possible outcomes. So when people deal with probability, you have to know that, there's a total number that is coming out of, there's a total number of items that is coming out of. And that's what they call it, total number of possible outcomes. You're taking a chance, what's the total number of chances? So my example is how many 6s are there out how many sixes are there out of the other numbers? So when we talk about the probability, so we'll say something like this, the probability of 6. You normally see something like that, okay? What is the probability of 6? Or what is the probability of getting a 6? What are the chances of getting a 6? When you think about probability, you're thinking about chances and things like that. So you want to make a fraction, and you say, first of all, you can write 2. There's 2 sixes out of all those numbers. And then on the bottom, you're right. How many numbers do we have altogether? 1, 2, 3, 4, 5, 6, 7. So 2 out of 7. So the probability of getting a 6 is 2 out of 7. And that's it. And then when you do probability, there's stuff called independent, dependent probability, and things like that. But this is the simpler one, the one that, tend to be covered in all of the tests that I spoke about before. Alrighty. All right, let's go down to ratios, proportions, and rates. All right, ratios are comparison of two quantities. Okay, and then when you see a ratio, this is what you normally see. This is how they normally write ratios in math. They write A colon B, A to B, or A slash B, which just could be like this. For instance, you can say it was 2 to 3, it was 2 to 3, and then it was 2 over 3 or 2 slash 3. Okay. 2 out of 3, 2 to 3, so that's how they write ratios in math. Now, I gave an example. There are 6 girls and 7 boys. Now, I have 3 different scenarios that I'm going to compare to get the ratios. So compare the number of girls to boys. So we're going to do that first. Girls to boys. So here they said that there's 6 girls to 7 boys. Okay, so there's different ways, 6 to 7. It can be 6 to 7, or it can be 6 over 7, or 6 slash 7. Okay, however you want to write it. Sometimes they say write it as a fraction. Okay, now that's for girls to boys. Now let's look at boys to girls. Okay. Now we talking about boys to girls. You look at boys, boys says 7. So it's 7 to 6, or 7 over 6, or 7 colon 6. Okay. So those are the answers for boys to girls. Now when we look at C, it says girls to total. Okay, so the girls to total. So the girls is what, 6? And the totals when you add the 6 plus 7. So 6 plus 7 is 13. So you write 6 to 13 or 6 over 13, and so on and so forth. Okay, so that's how you do ratios. Okay, that's how you do the ratios. Just keep it simple. Keep it simple. All right. All right, let's go down and do proportions. Okay, so proportions is 2 ratios. When the 2 ratios are equal. Okay, when the 2 ratios are equal, and you, like they said right here, you can cross multiply to solve it if need be. Okay, that's one way. You could reduce them, you could turn them to decimals. There's so many different ways to do these math problems. So my example, I said, we're trying to see if this is a proportion. In order for it to be a proportion, it has to be true. Proportion has a direct relationship. Okay, so if you have 3 over 4 equals 6 over 8, when you cross multiply them, you can say, okay, what's 6 times 4? 6 times 4 is 24. What's 3 times 8? 3 times 8 is 24. 24 is equal to 24. So yes, it is true. This is a proportion. It has to be true to be a proportion. Okay. Now, some people can look at it this way. So many different ways to do it, like I said before. Some people can say, okay, this is a prime fraction, this is not. So I'm going to simplify this fraction, and I'm going to see, and I'll get 3 over 4, and 3 over 4 is equal to 3 over 4. That's another way of doing it. And there's other ways also. So let's look at this. 1/2 is equal to 3/5. Is this true? So 2 times 3 is what? 2 times 3 is 6. And then 1 times 5 is 5. Is 6 equal to 5? No, they're not equal. So no, this is not a proportion. In order to be a proportion, it has to be equal. Okay. So it has to be like an equivalent fractions. Yeah, probably heard of that, equivalent fractions. All right, so let's keep it moving. All right, let's talk about rates. Rates. Okay, unit rates. All right. Now, the rates of the ratio comparing two different units. Okay. So for this one, we're gonna talk about miles and hours. Okay, that's a very common one. Miles and hours. Okay, so I made an example. The train drove 100 miles in 2 hours. Find the train's unit rate in miles per hour. Okay, so when you're trying to find the unit rate, you're trying to find something per unit, per hour, per minute, per second, over one, something like that, over one. So the way you do it right here, per hour, you want to write it as in division, as a division problem. So 100 miles, okay, in 2 hours. Okay. So pretty much what you want to do is simplify this, reduce it. Okay. You can use the greatest common factor again. So let's divide it by 2 because 2 can go into 2 and 2 can go into 100. Okay. So this is one way of doing it. 100 divided by 2 is 50. So there's 50 miles. And 2 divided by 2 is 1. So 50 miles per hour. Or you can just say 50 miles per hour. Okay. So that's it. 50 miles per hour. So the train drove 100 miles in 2 hours. Find the train's unit rate in miles per hour. So the train's unit rate in miles per hour is 50 miles per hour. And that's how you do that one. Okay. Now, all right, so the next one we have is called simple interest. You go to the bank, simple interest is not compounded every year. It gets more and more. It's just a straight up formula for simple interest, how much you're going to make over a certain amount of time. All right, so the simple interest formula, okay, is I equals PRT. I stand for interest, P stands for principal, R stands for rate, and T stands for time. So I equals PRT. I equals PRT. I equals PRT. Straight to the point. Okay. So I made an example here for you. Michael deposited 5,000 in an account that earns simple interest at an annual rate of 5%. If the money is in his account for 4 years, how much interest will he earn? Okay, so first of all, we're going to write the formula down. I equals PRT. Okay, so we're looking for the interest. So we bring this down. Okay, equals, I'll make this look like an I, okay. I equals, so what's the principal? The principal is the amount that he started out with. Okay, the amount that he deposited, the amount he started off with. So that's 5,000. So we're going to say 5,000 times PRT means P times R and R times T. Okay, they multiplying each other. Okay, anytime the letters are together, that means multiplication. So the principal times the rate is 5%, but we can't you keep 5%, we have to change it to a decimal. And before I said when you have a percent, you change it to a decimal, there's an imaginary decimal point, and you move it 2 places over to the left. Okay, so it's 0.05. Or another thing you can do, you take the number and you divide by 100. When you divide it by 100, it moves in 2 places over to the left also. So we got 5,000 times 0.05, okay, times the time is in years. The time is always in years. So if you have it in months, it's going to be a fraction. But since we have 4 years, we can just put 4 right here. If you have a half a year, that's 0.50. We have a quarter of a year. How much is that? How much is that? They say once you split it, fourth, that's going to be what? 0.25. Okay. But half of a year would be 0.50. But when they say time is always in years for this formula. Okay. So what you have to do is multiply 5,000 times 0.05 times 4 and see what you get as far as the interest being saved. Okay, let me check real quick. All right, so we got 5,000 times 0.05. And give you a chance to write this down. Times how many years? 4 years. Okay, so I have as far as my interest, which makes a lot of sense. I could have did that in my head. It's $1,000. Okay, so the simple interest would be $1,000. Okay, $1,000. So if he had $5,000, which earns 5%, interest 5% rate at a 5% rate for 4 years. He'll have an extra 1,000. So it would be 5,000 plus 1,000. So he would have made $6,000 after, at the 4th year. All right, thanks. That sounds about right. All righty, we're getting down to the end, somewhat. All right, measurements. Woo, conversion factors and all those wonderful things. Okay. Common conversions. Okay, so I have so many different ones down here, but I'm going to do one as an example, and you can apply that method. Well, I'm going to do two. You can apply this conversion factor method to the rest of them. Okay. So the conversion factor is the truth, whatever they give you. 1 foot is equal to 12 inches. 1 foot is equal to 12 inches. That's the conversion factor. That's the true statement that you use to figure out something that's not as straightforward. Okay. So let's do a conversion factor. I haven't done conversion factors in years, but let's get it started. Once you know, you know. Once you know, you know. Okay. So how many inches are in 4 feet? Now, some people can look at this and say, oh, I know how to do that. Oh, that's easy. Okay. And you can do it that way. And I'll tell you that also. But the way we can do this, we can start out with 4 feet. Okay. And this is how you do you put the conversion factor down. And then I have right here, 1 foot equals 12 inches. Okay. So we're going to put this right here as a fraction. We're going to put 1 foot, I'm going to just put 1 FT, and I'm going to put 12 inches right here. Okay. So you want to set it up. When you do the conversion factor, set it up so the units are across from each other. Because when they're across from each other, you can cancel them out. Foot and feet, we're going to pretty much say they're the same. Okay. Now, what you do after this, you set the conversion factor up, you cancel out what cancels, and then you just go ahead and multiply straight across. What is 4 times 12? Okay, that's 48. So 48 inches. Okay. So basically when they say how many inches are in 4 feet, normally someone can say, oh, okay, since 1 foot is 12 inches and 4 times 12, they can get 48. So some people could have just looked at it and say 4 times 12 is 48. Okay. But this is a good tool because sometimes it's not going to be things you can do it right in your head. Sometimes it's good to have a strategies because you might have to go from inches to centimeters. And then once you set it up like this and keep crossing out, you'll be able to get it. Not inches, centimeters. You might have to go from feet to centimeters, so you might have to do it like three different steps. All right, so that's this one. Okay, so let's go here. How many feet are in 144 inches? And some people can do this in their head. Oh, bam, bam, bam. But we're gonna start it off by doing it step by step for people that might be a little confused. And we know the conversion factor because it's right here. You have to know the conversion factor. If you don't, it's going to be a struggle. But if you know the conversion factor, you know how to set it up. That will help you out. Since I have inches at the top, I'll put inches down the bottom. And I'll put 1 here. And then I'll put foot right there. Okay, so I just flipped it around. Since inches is here, I cancel out the inches. And I multiply straight across. I'll do 144. Okay, and the bottom number is 12, so you're going to divide. So 144 divided by 12, and the answer would be in feet, will be 12 feet. Okay, so basically, let me make sure that's neat. Okay, so basically, you have 12 feet. 12 feet makes 144 inches. And then some people will be like, well, okay, it says 1 foot is 12 inches. If it's 144, I just take 144 and divide it by 12. Okay, so some people normally think that way. But for people that don't normally think that way, then it's always good to go through and do the conversion factor. And like I said, the conversion factor is really good because you might get units that are really big and you got to convert them to something that's really small. And this is just an organized fashion of how to see everything. Okay. How to see, you can use this in chemistry also, and physics and all the different things. All righty. We finished with that. Play that out. All righty. Let's see what's next. All right, base arithmetic and word problems. Okay, so the base arithmetic and word problems, right, that relies on understanding operation, okay, like order of operation, you know. I'll go over that. I have a video on order of operation too. I did a video on quadratic formula, order of operation, exponents. We did multiplication. I did division, and I think that might be it. Yeah, yeah. I might be more, but those are the main videos that I did. All right, so yeah, you know, basic arithmetic. So I'll go through this again, you know, prim this, you do parentheses or brackets or any type of grouping symbol. It could be a bracket. Okay, I'll go this real quick. Please excuse. Okay. That's an S. So parentheses will be first. It could be parentheses. It could be a bracket. Exponent, like I said, to the second power. Multiplication or division, whatever one comes first from left to right. And addition or subtraction, whatever one comes first from left to right. Once you follow that order, and you know, if you have more than one operation, you follow that order to see what comes first. Okay. And then there's all other things. It just relies on what type of operations they're going to give you for the basic arithmetic and word problems. And then for word problems, you know, sum means addition, different means subtraction, quotient means division. Product means multiplication, you know, just being able to, you know, recognize those clue words, you know, that will help out too with the basic arithmetic and word problems. All right, so number 8, like I said again, I did a video for exponents and roots. Okay, more exponents, but let's see. All right, so let's go ahead to exponents and roots. Okay, so let's see. All right, so we're going to do the product rule. The product rule. Product means multiplication. Okay, so right here, say x to the a times x to the b is equal to the x to the a plus b. Sometimes people see the letters and be like, what is going on? So what I did, I put the numbers here. 3 to the second times 3 to the fifth. And when you multiply, the product rule means multiply. So that's a multiplication. So 3 to the second times 3 to the fifth. They say when you multiply, guess what? You add the exponents. So it's 3 to the 2 plus 5, which is 3 to the 7. Okay. And then if I had something like 4 to the 6 times 4 to the 7 would be 4 to the 6 plus 7, which is 4 to the 13. Okay, so the product rule is called product rule. You multiplying. These numbers right here are called bases. Okay, the big number is called the base. When the base is the same and you multiply them, you have to add the exponents. Okay, add the powers. Okay. Now we're looking at the quotient rule. The quotient rule right here pretty much is saying you subtract. Okay, so it's saying, look, it says x to the a divided by x to the b is equal to x to the a minus b. So I wrote it right here. So 7 to the 8th divided by 7 to the 4th is equal to 7 to the 8 minus 4, which is 7 to the 4th. Okay, so when you're dividing bases, told you the big number, you subtract the exponents. Okay, so if you have 4 to the 8th divided by 4 to the 2nd, you're going to get what? 4 to the 6. Oops, that's a big 6. Ooh. You're going to have 4 to the 6th power. Sorry. Because you subtracted. You get 4 to the 8th minus 2, which is 4 to the 6. Okay, so that's the quotient rule. When you divide the same base, then you subtract the exponents, the power rule, the product rule, and when you multiply the same base, you add the exponents. Okay? All right, let's go. Let's keep it moving. Let's go down, 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 down. All right. Let's look at the power rule. Okay, power rule, power rule. All right, so right here it has x to the a. X to the a to the b power is equal to x to the ab. Okay, so basically what that means that you have 8 to the 4th power and times 3. You have it like this. Okay, so what you do with this is the power rule. That means you multiply the powers. So this would be 8 to the 12th. Okay, so if you get 2 to the 3rd, okay, to the 2nd power, that'll be 2 to the 6th. Or if you get 10 to the second, and then you have to the 8th power. Oh, look at that. My hands are getting tired. Okay, to the 8th power, that will be what? What? Right. 10 to the 16. Okay, so that's the power rule. When the two exponents are next to each other, a power raised to a power. Okay, that's the power rule. Okay, power rule, power rule. Sometimes you have to go through and break it down more, but that's it for right now. Okay. So the zero exponent. There's a rule in math, and I did this in my exponent video. Anything to the 0 power is equal to 1. Everything to the 0 power is equal to 1. Okay, so 2 to the 0 power is equal to 1. 5 to the 0 power is equal to 1. Q to the 0 power is equal to 1. Okay, anything to the 0 power is equal to what? What? 1. What? 1. Okay, so 4 to the 0 power is equal to 1. Okay, this is 10,000 to the 0 power is equal to what? 1. That's a rule in math. Everything to the 0 power is equal to 1. Okay, let that stick. Let that stick. All right, let's go on. Let's get this out and in. All right, negative exponents. Okay, let's go through this. All righty, so let me. Okay, so right here we have 2 to the negative 1 power. And it says it here, you have x to the negative a power is equal to 1 over x to the a power. Okay, so this is what I normally do. When I do negative exponents, I normally tell people to put it over 1. Put your whole number over 1, right? And when something is to the negative power, you have to flip it in order to make it positive. So you have this. So when you flip this, it'll be 1 over 2 to the first power, which is 1 over 2. So 2 to the negative power, 1 power is really 1/2. And you put it in the calculator, it'll do it. It'll make it positive because you have to drop it down. And now you have this 4 to the negative 2 power. I would say put it over 1. And then you flip it, it'll be 4 to the second power, 1 over 4 to the second power, which is 1 over 16. Okay, so this is how you deal with negative exponent. And let's say, for instance, you had something like 1 over 3 to the negative 2 power. So in order to fix it, this is already on the bottom. You would just flip it, and it'd just be 3 to the second power, which would just be 9. Okay, you just flip it from the numerator to denominator, denominator to numerator. You just flip it and you make it positive, and that's how you solve that. So yeah, so we'll stop there. There's more, there could be more, but I think that's the basics. That's really good. All right, now fractional exponents. So let's say, for instance, you have 3 to the 1/2 power. Okay, if you have 3 to the 1/2 power, and this is this is like an exponential, this is the exponential way. Let's say you want to change it to power, the square root, the root way. The way you would do this is you write your root. This number right here, the big 3 goes under here. The 2 it goes for the square, and then the 1 goes here. Okay, so this is called the index right here. The 2 is the index. So whatever the denominator, that becomes the outside, and then the 3 goes inside. So that's how you fix that. Then keep the base or the big number the same, but the 1/2, this right here will be the power number, and then this right here will be the root number, and then this right here will be the number on the inside. Okay, and I'll give some more examples. You got to practice with it. So for this one, you have 5 to the 2/3. And again, you make the root. The 5 stays under it, on the bottom. The 3 goes on the outside, and then the 2 goes on the inside. And so if you really wanted to see what the final number would be, it would be 25, because 5 to the second power is 5 times 5. Okay, so this is how you go from there. This is how you do that. Now, if you want to go backwards, let's say you want the square root of 64, and you have it like that. 64 to the first, let's say that's to the first power. you go backwards, that's 4. Sorry. If you go backwards, it'd be 64, and it'd be to the 1/2. Okay, the 64 stays the same. The 1 stays on top, and then the power goes on the bottom. Okay, so this is how you change something from exponential notation to power or square root root notation, because it's not always a square root. It's sometimes it's a cube root and things like that. So that's how you deal with that. Okay, finish that. All right, let's see what's next. For number 9, problem solving and reasoning. Yeah, relies on a logical application. There's so many different things you can do with that. Sometimes you can figure it out by elimination. And then 10, mathematical modeling. It relies on translating real world scenarios into your mathematical expression or equation. Like the sum of x and 5 is equal to 20. So something like that. This is just one I can just give you. The sum of x and 5. The sum of x and 5 is, let's say the sum of x and 5 is, oh, let me just type it so it can be neat. Let me give you something neat. Yeah, let me text this for you so it can be neat. Okay, let's say I said the sum of x and 5 is 18. Okay. Okay. So let's say I said the sum of x and 5 is 18. Okay. So sum is addition, right? So you would do something like this. You'll say x plus 5 is equal sign is 18. Okay. So yeah, it depends on what they ask you. They might have you, talk about real life things, or might have you do math translations and so on and so forth. But yeah, so as I go through this, so as I go through this, let me get that out the way real quick. Okay, let's finish that. Okay. Now, please check out our tutoring, or check out our tutoring services and products for K-12 students. And please join, get assessed. I have free assessments in math and ELA for everyone, even for adults. So I have free assessments. You would have to sign up for my assessment consultation meeting. And like I said, tutoring services and products for K-12 students, teachers, and others like nurses for the T's and things like that. But you can check everything out by scanning my QR code right here. Then this QR code will take you to all my services, for the most part, majority of my services, whether it's tutoring. Like I said, I have many tutors. They tutor online. I have some that visit the library, and yeah, I have a lot of different services. Books. I have alphabet books, timetable books, math notebooks. So, if you want a math notebook to keep your things in, I have a math notebook with notebook paper, grid paper, graph paper, dot paper, everything all in one. So if you scan this, you can see all my products and all my services. I do workshops to help kids get into college, and homeschool parents to make sure that their child is ready for homeschool, colleges, elite schools, people that want to get their kids into elite schools, and so on and so forth. So there's a wealth of resources. I have a wealth of resources, and especially for teachers, I have study guides for them to get ready for 5003. Praxis 5003, 5733, and 5165. I have YouTube videos on math anxiety and multiplication. I have many things. Just check out my math channel. And you can see that. If you need to contact me, if you scan this QR code, will be able to contact me also. So let me stop sharing so I can say. It was a pleasure. I had so much fun. I had so much fun with you. It was a pleasure. Oh my goodness. It was such a pleasure being able to go through everything. And the hope, it was just a pleasure to be able to go through everything. So I would just say, if you're really trying to study, I would just say go back and review any of the areas that you felt that were a little shaky. The formula sheet we discussed, is your best friend. Keep it handy, and use the notes that you gathered from me, whether you went through and typed it in or you wrote them into the formula sheet that I gave you as a bonus. Um, if this video if this video has helped you feel more confident about your upcoming tests, please hit the like button. It really helps the channel to grow. It really helps. And if you want more practical, tips or study guides, and want to practice problems and strategies and things like that, make sure you subscribe and ring that notification bell so you don't miss anything. So leave a comment below and let me know which skill you found most helpful, or what other topics you'd like for me to cover next. Okay? So until then, make sure you keep practicing, you keep pushing, because you got this. Thanks for watching, and I'll see you in the next video. Peace.